Hey guys, if they give you Kp or Kc and ask you to calculate the other one based on an equilibrium reaction, all you need to do is plug what you know into this formula. Kp and Kc are mathematically related through this formula here because concentration and pressure differ by a factor of RT when you look at the ideal gas law. Now the only trick here is delta N, the exponent on your factor of RT, needs to be the number of moles of gas on the right-hand side of your equilibrium, and this N left is the number of moles of gas on the left-hand side of your equilibrium. Let's check this out. In this case, they told us Kp was 41. They asked us to find the new Kc. Here's my RT. Now you're always going to use 0.08206 because it's in ATM, and Kp, you need ATM for it to be a legit Kp. Your temperature, they gave it to us as 400 K. And our delta N, the number of moles of gas on the right minus the number of moles of gas on the left. Well, I have 2 on the right, and I have 4 on the left. See, 1 and 3 make 4. Now I'm going to crunch this number on the calculator just so it's a little easier to handle. 0.08206 times 400 to the power of -2 turns out to be 0.000928. The way to solve for Kp is simply to divide both sides by 0.000928. And when I do that, I get 44174, or 44,000. In this case, the answer may be given as 4.4 times 10 to the power of 4. In any case, Kp and Kc are mathematically related. Now I want to riff for a second about why that's even true. I want to show you this equilibrium here and write down the equilibrium expressions for Kp and Kc. Kc is the concentration of NH3 squared, see the coefficient became an exponent, all over N2 times H2 to the power of 3. Sweet. Kp is the pressure of NH3 squared. See, it's the same, but it's pressure, right? All over the pressure of N2 times the pressure of H2, but that's cubed. All right, so the exponents are all the same because the coefficients are the same, whether we're using concentration or pressure. It's just the numbers we're plugging in that are different. But check this out. PV equals nRT, according to the gas law. Concentration is in moles per liter. That's moles, and that's liters. So, pressure, it turns out, is concentration times RT. Let me write that out again. The pressure is concentration times RT. So I'm going to replace each of my pressure things in here with concentration times RT. The pressure of NH3 is, well, the concentration times RT, all squared. See, that's the pressure squared, divided by the pressure of N2. See how I'm rewriting that? And the pressure of H2. But the pressure of H2 is cubed. Let me factor this out for you too. I'm going to factor out all my concentrations. I get my NH3 squared come out. I get my N2 coming out. And I get my H2 cubed coming out. But what am I left with? I'm left with RT squared on top and RT to the 4 on the bottom. Oh, take a look. That right there is RT to the -2. Does that remind you of anything? Heh heh heh. And this, conveniently, was Kc. Yeah, that just oh, I wish I would have written that where you were looking, but look, Kp turned out to be Kc times RT delta N, which is exactly the formula we used over here. Party time. That's where it comes from. I don't know if you cared. You probably only wanted to use the formula, but here's your formula. Use it. Best of luck.